Hi, I'm Cody.
Hi, I'm Melissa. Hi, I'm Montana.
Hi, I'm Charlie.
Remember to keep your hair up and always wear closed-toed shoes in the lab and safety goggles at all times.
Our project has to do with the electrical conductivity of solutions. We are testing a lot of different substances to see if they can produce an electrical current and make a light bulb glow.
For this lab, you will need batteries, a light bulb unit, alligator clips, a beaker, baking soda, salt, hydrochloric acid, distilled water, lemon juice, sugar, laundry detergent, goggles, and a stirring stick.
This is the light bulb. You just gotta attach one alligator clip to one end, a different alligator clip to the other end. But with this end, you have to connect this half to the 9-volt battery, and then attach another alligator clip to the other end of the battery, and then put both of them into the solution.
Our first test uses just distilled water. Get your beaker and fill it up halfway with water.
Use the sink. Just use the
Just makes
sink.
perfect.
So for our first test, we're going to use just distilled water, and we're going to see if it carries an electrical current. So we have our batteries right here set up with our light bulb and the wires. So I'm going to put the 2 alligator clips in the water, and you see that the light bulb does not light up in just distilled water because there's nothing in it.
This is the drawing of our circuit, and now I'm going to explain why the water did not work when we tested it with the electricity. The problem is that H2O has no ions. So when we put the electrical current through it, there was nothing to break up and pass the electricity into the light bulb. So because there's no ions, there's no electricity.
For this test, we will be testing the conductivity of salt in the solution. So just take your salt, put it into the water. Make sure you stir it. Then before testing, make sure that the ends of your wires are touching your batteries, and put the other ends into the solution.
The reason that the light lights up when salt is dissolved in water is because when you put 2 metal poles in a solution, one positive and one negative, and turn on a battery, you are making a voltage difference between the 2 rods. The sodium and chlorine ions actually separate in water, turning solid NaCl into Na positive and Cl negative ions that can move freely in solution. Thus, the electrical current is being carried from a positive to a negative, causing the light bulb to glow.
And now we're going to clean out our NaCl with the water. Just dump it out. We're going to use some hot water to clean it out of all the salt. And we're going to refill it again with distilled water for our test tip.
Okay, next we're going to do baking soda. So just fill your beaker with baking soda and the water. And then stir with your stir stick. And then we're going to test the charge. So make sure that the 2 ends are touching the batteries and then into the alligator clips. And then you can see that the light bulb does not light up.
Now for our baking soda in solution. The problem with our circuit was we did not have enough voltage to light the light bulb. As you can see, this is an ionic compound, so it should have been able to light the light bulb, but because our solution was not concentrated enough and we did not have enough power, the light bulb was not able to be lit.
Okay, remember to clean out your beaker before the next test. For the next test, we will be using hydrochloric acid. This acid can burn you if it gets on your skin, so please take caution while using it. Okay, so for this next experiment, we're going to do hydrochloric acid, which is HCl, in pure distilled water. So just make sure that the prongs are touching on both ends of the battery unit, and then enter in the alligator clips. And as you can see, the light shines very bright.
Similarly to salt, HCl ionizes in solution. It is a strong acid and therefore made our light bulb glow super bright. It's a great conductor of electricity in solution.
Okay, make sure to just wipe off the alligator clips so that each test is clean and pure. And then also wash off your stick, your steering stick.
For the next test, we will be using regular sugar. Remember to stir it. Can you hold the wires?
Thank you.
And then test the solution. As you can see, not a good conductor.
When we tested simple sugar in solution, it did not work because there are no ions. Because there are no ions, this solution did not make our light bulb glow.
And after each test, make sure that you pour your solution down the drain and rinse it out with water before filling it back up for the next test.
For our next test, we're going to be trying laundry detergent, which I have in this little container here. So we're going to have just a little bit in solution right now. And we're just going to mix it in. And we're going to test this, hold the batteries to the alligator clips. And we can see that the light bulb does not work, so we can tell that it's not a good conductor of electricity.
We tested laundry detergent in water. It unfortunately did not light our light bulb. Laundry detergent contains many different kinds of salts, along with a lot of other elements. The problem was, our solution made one of our wires very fizzy when we added more light bulbs. This added voltage to our circuit and helped the electricity move through one of the wires, but unfortunately did not make it to the light bulb. So, laundry detergent ended up being a poor conductor of electricity, not enough to glow the light bulb, but enough to make our wire fizzy.
For this next test, it's just laundry detergent, and if you watch carefully when you put them both in there, they cover in bubbles. And look at the light. As you can see, it is a good conductor. And look at these prongs.
The next thing we tested was plain laundry detergent. And after our previous experiment, we were very interested to see what would happen with just laundry detergent. So for this experiment, we added several more batteries. So laundry detergent made this wire fizzy, and then after a little bit, made our light bulb glow.
Well, we put in just vinegar, and we put the prongs in and attached them to batteries. And the light isn't turning on, but one of the prongs is bubbling in solution.
If you don't want them, I'll take them.
So I think something's gonna happen. And maybe just go try to see if you can see
there
what's...
is an electrical current. Hold on.
It's just not strong enough to do the light.
It's just not.
Can you see?
Yeah,
You can see how the red wire has a bunch of bubbles coming off of it. So, should we say something about adding more batteries, or
We kind of added a lot of batteries.
we've added more
We've
batteries?
made this an unsafe environment.
But there's definitely an electrical current. It's just not strong enough
To light this.
to light.
to light the light bulb. Yes.
We added 5 batteries.
Now I'm just pouring the vinegar into the water. Ooh. Filled up a lot. Wait, there were 4 batteries before. I'm just gonna test it with 3 batteries. We need to put more batteries.
Add another battery. The voltage really helps the conductivity of the solution.
It's starting to bubble again, just like in the plain vinegar solution.
Not really. Oh, a little bit.
It's bubbling a little bit, but it just doesn't have enough voltage.
Yeah.
Yeah, gotta add it. Bubbling a lot more again.
Yeah, it's getting up there. Okay, so with our power unit, vinegar does not work, but it is known as a weak conductor. So through a different unit, it could possibly light the light bulb up a little bit.
Our next test was water with vinegar. And for this test, the first time we did it did not work. But after doing laundry detergent in water and laundry detergent without water and seeing that our wire was fizzy, we decided to try it again using more batteries. And when we added the batteries, again, our wire began to bubble, meaning that water and vinegar together was a poor conductor of electricity, but did conduct some electricity. Next, we just tested plain vinegar with the added batteries, and again, the wire was fizzy, meaning that just vinegar can also conduct a small amount of electricity.
Next test, we'll be testing lemon juice in water. Make sure you pour in the lemon juice and then stir it up. And then test your prongs. Good conductor.
For our last test, we tested water with lemon juice. For this experiment, our light bulb ended up glowing. This is because lemon juice contains ions. So, have you noticed the trend between when the light bulb glows and when it doesn't? What could it be? Ions.